Okay, in number 57, you have to describe, and 60, you have to describe the transformation of the function from f of x to g of x. So we have the 4 here, which is your k value. Sometimes, most times we're used to seeing it over here, plus 4. And then that negative is your a. So negative 1 is a. So the negative tells you that it's reflected over the x-axis. So you're going to write f of x is reflected over x-axis and translated up 4 units to get g of x. So that's what happened to f of x to make it into g of x. For number 60, you have a 4, again just like number 57, that's your k value, and then here this is your h value, that 1. So this one is going to be f of x is translated 1 unit right and 4 up to get g of x. In 63 and 66, you have to convert from log form to exponential form. So remember, on the other side of the log is the exponent. So on the other side of the log is the exponent. So this is the exponent, this is the exponent. Whenever you see ln, like you do here, that means that the base is e, okay? And what you see here, it's what it equals. So what I mean by that is, for number 63, this becomes base e to the first power, because that's your exponent, equals e. Okay, so this, let me highlight it. This e right here is this e right here. Okay, for number 66, the base is e, the exponent is negative 2, and it equals 1 over e squared. Okay, that's that. Okay, for these 3 problems, we're going backwards. We're given the exponential form, and you have to write it in log form. So, just write it. The base is e, so that means we're going to use natural log ln of 20.0855 ... equals the exponent, and that's it. For 72, natural log, so this equals natural log of 12.1824, and you have to include the ... equals the exponent. And then for 75, same thing. We're going to write a natural log of, hold on. I need to simplify this. So this e to the third is the same as e to the third to the 1/2, because that's what square root means, right? So this is e to the 3/2. So when I write natural log of 4.4816 ... that equals the exponent, which is 3/2, or 1.5. So for 78, you just punch it in the calculator, natural log of 18.31, and so that gives you approximately 2.907, rounded to 3 decimal places, so that would be the answer right there. So for 81 through 87, we're simplifying using the properties to rewrite the expression. So let me just change that real fast. For 81, natural log of e squared is just 2. And for 84, because this part right here is 0 because of that 0 right there, so 7 times 0 is 0. And then on 87, natural log of e to the natural log of e is natural log of e. Because, again, remember what this means? We're saying this here means that we have a base e. We want to know what power makes it equal to this. Like that. So then we could see here that the unknown is the exponent right there. So that's the answer right there. Natural log of e. Okay, so for number 90, the x plus 1, that's where we get the h. So h is actually negative 1. So that means that the x's are going to be subtracted by 1. They're going to be decreased by 1. So we're going to say x minus 1. So the points, and that's the only transformation, right? So 1 minus 1 is 0. And then e minus 1, that's 1.7. Okay? And so that's what we're graphing. So the vertical asymptote, since there's a translation to the left by 1 unit, because that's h is negative 1, vertical asymptote is x equals negative 1. So right here, we draw the asymptote, and then 0, 0, and 1.71. So about here. Okay? Like that. Connect the points. And it's also asking you to give the domain, vertical asymptote, we already did that, x-intercept. So the domain is everything greater than negative 1. So all numbers greater than negative 1. Now I know it didn't ask you for the range, but the range is all reals. And the x-intercept is 0, 0, which also happens to be the y-intercept. Alright, so for 93, you have natural log of x plus 8. So it's asking you to describe the transformation. So basically the graph translates to the left 8 units. And so in green you see the points here that show the translation to the left 8 units. So I'm still going to go ahead and graph it. I asked you guys to graph it. So negative 7, negative 8. That's where the asymptote goes right here. Erase that point right there. And then negative 7, 0. And negative 5.3, 1. So about here. And it goes, now if you want to see where it crosses the y-axis, the y-intercept, you would make the x equal to 0, so then that would give you, and I'll put it here on the side, natural log of 8. So the x-intercept is the natural log of 8. I'm sorry, I'm going backwards. It's the y-intercept. So it would be like this. The y-intercept is 0 natural log of 8. So that would be natural log of 8, about 2.1. So 0, 2.1. So that tells you where it crosses the y-axis. So about here. Okay? Connect the points. And there's the graph. For 96, the translation is up 4 units. It goes up 4 units. So the vertical asymptote, and I forgot to put vertical asymptote. So here the vertical asymptote would be x equals negative 8. The domain is everything greater than negative 8. Oops. That, and the range is all reals. So for 96, you have no translating left or right, so then the vertical asymptote goes right here, right over the y-axis. And then you have the point 1.4 and the point 2.75. So about here. And then you connect. Like that. Okay? So the domain is all numbers greater than 0. The range, all real numbers. It has no y-intercept because there's an asymptote there. As far as x-intercept, you would have to, again, that's something that comes in a later lesson, but you set the y equal to 0 and then you solve for x, right? So it's going to be plus 4, so we subtract 4 from both sides. And so natural log of x equals -4, so e to the -4 equals x, okay? So we do that, natural log -4, 0.018, so 0.02 approximately. So the x-intercept, approximately 0.020. Okay, so there it is.